Today we are going to learn about optimizing Pandas Group B for performance. We'll explore techniques to enhance Group B operations in Pandas, crucial for efficient data analysis with large datasets. Welcome to our video on optimizing Pandas Group B operations for performance. In data analysis, handling large datasets efficiently is paramount. Today, we'll explore various techniques to enhance your Group B operations, allowing you to manage and analyze data more effectively. By the end of this video, you'll be equipped with the skills to identify bottlenecks, leverage parallel processing, and utilize memory management strategies to optimize your data workflows.
The first step in optimizing Group B operations is identifying where the performance bottlenecks lie. Understanding which parts of your code are slow is crucial. Profiling tools like %timeit in Jupyter Notebooks or Python C Profile can help you gauge execution time. Look for operations that take disproportionately long to execute, especially in datasets with millions of rows. Often, the size and complexity of your data impact speed. Identifying whether I/O operations, data manipulation, or aggregation functions are slowing things down can guide you on which specific techniques to apply. Addressing these bottlenecks can significantly improve the efficiency of your Group B operations.
One powerful method to enhance Group B performance is using categorical data types. Categorical data types are efficient for memory and computational performance, which is particularly beneficial for columns with a limited number of unique values. Converting your grouping columns to categorical types can lead to faster Group B operations. This is because categorical types use integer-based representation internally, which speeds up comparison operations. Implementing this involves converting data types using pandas. A type category method. Consider a dataset with a country column. Converting this to a categorical data type can greatly enhance the speed of operations like aggregation and filtering. This technique is especially effective when dealing with columns that have repetitive, non-unique values. Parallel processing is a game changer for speeding up data processing tasks. Dask is a powerful library that extends pandas to handle larger-than-memory computations by parallelizing operations. Integrating Dask with pandas involves converting your data frame to a Dask data frame using dd.from_pandas. This allows you to perform Group B operations in parallel across multiple cores or even distributed systems. For example, a large dataset that takes hours to process with pandas can be reduced to minutes with Dask. This is particularly useful in environments with limited memory, where Dask efficiently manages data chunks, improving both speed and resource utilization. By using Dask, you can scale your data processing capabilities without changing your existing pandas code significantly. Memory management is crucial when dealing with large datasets. Efficiently managing memory involves using data structures that minimize the memory footprint. This can include using data types with lower precision, such as float32 instead of float64, where applicable. Memory profiling tools, like memory_profiler in Python, can help identify memory-intensive operations in your Group B processes. Consider breaking down operations into smaller, manageable chunks and using generators to handle data streams efficiently. Best practices also involve cleaning up unnecessary variables using Python's del statement and employing garbage collection to free up memory. By optimizing memory usage, you can ensure that your Group B operations run smoothly even on constrained hardware.
The transform and filter methods in pandas offer powerful ways to manipulate data within Group B operations. Transform applies a function to each group and returns a data frame with the same shape as the input, which is useful for normalization or scaling tasks. Filter allows you to exclude entire groups from your results based on a condition. These methods help in performing complex transformations efficiently. For instance, using transform to calculate z-scores or moving averages across groups can be done without reshaping your data frame. Applying filter to remove groups with less than a specific count can optimize your data processing pipeline. Understanding when and how to use these methods can significantly boost your Group B performance.
In this case study, we explore a real-world example of speeding up a large dataset analysis. Initially, the dataset, consisting of millions of rows, experienced significant delays during Group B operations, particularly when aggregating sales data by regions and product categories. By applying various optimization strategies such as converting categorical columns, utilizing Dask for parallel processing, and optimizing memory usage, substantial performance improvements were achieved. The time taken for Group B operations reduced from hours to just under 30 minutes. This case study highlights the practical application of the techniques discussed, illustrating how identifying bottlenecks, leveraging appropriate tools, and following best practices can transform your data analysis workflows. Lessons learned include the importance of profiling, the power of parallel processing, and the impact of efficient memory management.
While Pandas is a versatile library for data manipulation, exploring alternative libraries can be beneficial for specific use cases. Libraries like VAX and Polars offer significant performance advantages, particularly for large datasets requiring fast computation speeds. VAX is optimized for processing out-of-core data, allowing you to handle datasets that don't fit into memory by using memory-mapped files. Polars, on the other hand, is designed for high performance, utilizing Rust under the hood for faster operations. These libraries can outperform pandas in scenarios involving large-scale data manipulations and complex computations. Understanding the strengths and limitations of each library can help you choose the right tool for your specific needs. Consider factors such as ease of integration, scalability, and community support when deciding which library to adopt for your data analysis tasks. Optimizing Group B operations can be challenging, and several common pitfalls can hinder performance. One frequent mistake is not using categorical data types for grouping, leading to slower operations. Another issue is performing unnecessary computations within Group B, which can be avoided by pre-filtering data. Failing to profile and identify bottlenecks before optimization can result in inefficient code. To avoid these pitfalls, adopt best practices such as profiling your code, using appropriate data types, and leveraging libraries like Dask for parallel processing. These strategies not only enhance performance but also contribute to more maintainable and scalable codebases. By avoiding these common missteps, you ensure that your Group B operations are optimized for both current and future data analysis needs. Long-term benefits include reduced processing times, improved resource management, and more efficient use of computational power.
As we conclude this video, let's recap the optimization techniques we've covered for Pandas Group B operations. From identifying performance bottlenecks and using categorical data types, to leveraging parallel processing with Dask and managing memory effectively, these strategies are vital for efficient data handling. Remember, continuous learning and practice are key to mastering these techniques. Explore further resources and tutorials to deepen your understanding. As you apply these skills, you'll enhance your data analysis capabilities, making you more proficient in handling large datasets. We invite you to explore advanced topics in data optimization and continue your journey towards becoming a data optimization expert.